Okay, we are good to go. Ravi sir, Amrit sir, we are good to go.
Yeah. So, before Jugal takes over, let me introduce you, all of you, to the Jugal. Am I audible?
Yeah.
Yes, yes.
Yes.
Yep. Yep. जब भी मिलता, I'll my audio is lagging. My audio is lagging, I think.
It is fine, Ravi.
Is it fine? Okay.
Yeah.
It's fine. Go ahead.
जब भी मिलता है मुझसे अंदाज जुदा सा होता है, चांद 100 बार भी निकले हमेशा नया सा होता है.
Wow.
After completion of BTech from Navrachana University, Jugal joined VIT for his masters, and every time he used to come to meet us at university during his internship, I think at Bangalore, and after joining, I think, John Deere in Pune. Every time he used to come up with something new, and I think that's why I felt that this share is very apt for him. Today, as Jugal joins us, his engineering. He was also, a student who did a project under me. So I'm very proud to have a Jugal. We all are very proud to have a Jugal, who is going to deliver a session today on a robots. So without wasting any time, Jugal, all over to you. Stage is all yours.
Thank you so much, Ravi sir, for this kind and informative introduction. Before I start, just let me tell you, for all the new students, whenever I'm trying to deliver something, if you are not able to get anything like any of the topic or words, what that means to, feel free to ask directly. Don't wait for the end of the presentation. Sometimes this happens for that, like for particular students not knowing that particular term, and there are plenty of other students are same like that. So feel free to ask directly at that point only, so it will clear that particular everything at the same moment. So let me start with topic today, that's the next generation robots, for that's AMRs and cobots. So these two are acronyms. AMR means autonomous mobile robots and cobot means collaborative robots. So be it for my this is me. Let me introduce my as well. I complete my BTech mechanical from Navrachana University, as Ravi sir just mentioned. Then go to the VA Vellore Institute of Technology, complete my masters in mechatronics as a gold medalist. And I have the passion for the robotics and automation, control systems, and circuit from the beginning. You can say from the 11th and 12th. From the other side, my hobbies are trekking, mountaineering, and volleyball. I'm state level volleyball player, and I also have national awards and state award for the field of mountaineering. And I'm proudly say that I was a senior under officer at that time when I was in college. So for the today's topic, we will go through some facts and information about the robots. What are the current problems, situations inside the factory or units, and then we go for the basic theories. Then what is the cobot and AMR, how it works, how we can program it. Then we will see some application, lastly conclusions. So let me start with the normal robot. So George firstly patent that in 1954, that robotic arm. You can see a robotic arm. There is a 3 degree of freedom. That one is here, one in linear direction, one is this direction. So he patented for first industrial bot in 1954, and collaborative with Joseph, but the company name is Unimation. And after that, the many other companies come into picture like Omron, ABB, Kuka, Fanuc. These are more popular nowadays. You can see these robots in many other factories, automobile industries. You can say in General Motors, in Mercedes Benz, in BMW, all are using ABB, Kuka, Fanuc, Yaskawa. All this. These are more popular. So if we talk about the robot, there are the types based on the construction. So we will start with the normal construction. If the robot axis goes into X direction, something like this, or Y direction, something like this, is called as a Cartesian robot, XY robot. If we add one more axis in a Z direction downwards, it becomes a gantry robot. So it will go to X direction, something like this, Y here, and Z here. So it becomes a gantry type. So these are the Cartesian robot comes as a box type. The robot will we can use inside the particular box. If the robot is like giving the motion in a cylindrical phase, like something like this, here your base is rotating like this, go up and down, and also left and right. You can see here, these are the terminology. Here it is rotating, go up and down, and also left and right. It becomes a cylindrical. Similar, if we change particular motion in up vertical, it becomes a Skara. It is rotating. Here is also rotating. It goes up and down. So it becomes a Skara. For the delta, there is a one like stable base is there, and we have 3 or 4 links, and this end effector goes up, down, left, right. It becomes a delta. And this articulated is most popular 6-axis robot, where all the joints are rotating. The more that is this is also called as an industrial bot, industrial robot. Thus, these are the types based on the construction of the robot. So if we change the type based on the application, so it may be the if I want to use the robot as an assembly, then it becomes assembly robot. For the machine tending, for the material handling, the paint robot, for welding, for the pick and place, these are the type based on the its application. Here you can see one, like you can, if you notice something, robots are same, like here here all are yellow, maybe it's white, but at the end it's different. It is because of the application. If it is used for welding, there will be a weld torch. If it is using for the paint, there will be a paint gun. If it is for material handling, there will be a gripper here, or if it's or special type of hooks for the machine tending. Or if it's a pick and place, some kind of delta, it will be a two finger gripper, 3 finger flickers, depends on the applications. So these are the major brands of the robots. If I'm talking about the industrial bots, this that I just mentioned here, these are the yellow ones or orange ones. So then there are Fanuc, Yaskawa, Kuka, ABB, Coles. Then if I'm talking about the collaborative robots, their majors are in Universal Robot, Fanuc, Yaskawa, Omron, and Kuka. And if I'm talking about autonomous mobile robots, like moving robots, then it will be a Fetch, Omron, Mir, the mobile industrial robot, Bastion, and Turtle, what is specifically just for the small turtle kind of thing. So let's see what is the basic components of first as an industrial bot, because it's the main basic before jump into the collaborative robot. So here there will be a base, there will be a mere axis of all the robots, there will be a end effector, there will be a control to control the whole robot motion, there will be a basic operator panel which will help robot to change its maybe speed, spring. If it's used for painting, it will also help to prevent flow of the paint. If it's a welding torch, it will also use for changing the parameters of welding, maybe voltage or current or something. And there will be a teach pendant for the teaching of the robot, what kind of joints there should be a move to write a program where the robot is working. So these are the basic components of the industrial bots. So Now you know the basic components of the robot. I need to select the arm, that is called end of arm tool. So based on the application, we will select the different arm tool. If I want to use as a spot weld gun, that will be a different arm. I will attach that at the end. If I want to use as arc welding, I will use arc torch as end of Effector. If I want to use that robot as a pick and place, I will use 2 degree of freedom gripper, 3 finger gripper, 4 finger gripper, sometimes magnetic gripper, depends on the application. If I want to use just for the inspection, then I will use a camera, vision system, 3D, X-ray, lasers, everything. You can use anything. If you want to use as a paint, like you want to paint something, or there will be a assembly kind of things, or a bigger assembly where you want to paint, or sometimes blasting, or sometimes cleaning process, or there you will use a paint gun or vacuum gun, depends on the application. If you want to use the sealant, like you are applying a sealant on particular, like in four-wheel drive and the windshield, you are applying first sealant and then you apply on the windshield. For that, robot can also be used as a sealant can. And if you want to use as a pick and place, but the the box, that particular object is light in weight and you don't fit inside the gripper, that size of is big but it's lightweight, you cannot fit inside the gripper. So where you can use suction cups like this. So it, what will we do, it will suck the whole air, and it will try to pull or push that particular object, and it will do the pick and place same as a finger grippers. Now let's see the axis of the all the industrial bots. There will, if I am talking about the 6 axis, then how it be? There is a one base which will continuously rotating like this. You can see the motion here. It is also rotating here. Then there will be a shoulder, one here. Then the third axis, that is elbow. There is a fourth axis rotating here. Second axis rotating here, and sixth axis rotating in legs direction. So you can compare this 6 degree of freedom robot with your hand. So if your hand, but right now the thing is your hand is one extra degree of freedom because of the shoulder. We have a ball joint, so we have here 3 degree of freedom, one here and three here. So four, 3, 4, 5, 6, 7. So we have 7, but if here in base robotic arm we have 6 degree of freedom. So this is the base. If you compare it, this is the base, this is the second axis, this is the third axis. And how you are noting axis 4, 5, 6, if you compare that with your wrist, there will be a roll, pitch, up and down, and yaw, left and right. There will be a roll, pitch, and yaw. These are the 6 axes here. So axis 4, 5, and 6 will be at the end of the robot. All three at the same position. So that is a actual joint axis. If I'm comparing with axis to the world coordinate. World coordinate means the robot coordinate will be at the base of robot. You can see here there will be a base here. Everything, every program when you are writing, it is with respect to a base. So what will we do, a robot will do, a robot will directly take its base as a 0 0 0. And if robot is moving in any of the direction like z, x plus, x minus, y plus, it will give the value with respect to a base. If the base is here 0 0 and a robot is here, you can see here x direction is in this direction, y is here, z is here. If robot is here, what will we give? X is 0 because it's in y direction. Y will it give? And z direction is some value. It will take 0 0 here and it will give value with respect to base 0 0 0. This is the world coordinate system. If you take a tool coordinate system, it will shift that particular axis to the end of the robot tool, or you can say tool. Now if you want to program in a certain way where only tool matters, the motion of tool is only required, not the robot, then you use tool coordinate system. So where you can see x is here, y, z, you can define as per your applications. The coordinate will go to here. Then there will be a user coordinate. If you are working in front of robot, there is a robot, there is a workbench here where you are doing a pick and place, but you want to use your own coordinate system with respect to your workbench. What will you do? You will define that this endpoint is my 00. That is your user coordinate system, this one. And there will be an object that you want to work, that will you define the object coordinates, that is xyz. Now if you want to program in certain way, you will give the robot that I will use this as my coordinates. In that way, this whole base coordinate system will directly jump here, and accordingly the program will start. And like there is one more external access, if you want to provide, you can provide with help of like guide rails. There is one extra degree of freedom is also given, like here industrial bot is on the rail, so it can go left and right. Here the fixture is rotating continuously, so by that way you also provide one external axis, where this is the one axis for here, and here the axis is in the upward direction like this. So now you know the coordinates, all the parts. Now we will see what are the types of motion. So there are actually three types, but basic there are two types: joint move and the linear move. As you can clearly see in the picture, there is a point 1, point 2, point 1, point 2. If you want to go to point 1, point 2, you directly give the command go P1 to P2. That's the basic thing. But how it will go, that defines the joint move or linear move. If there is arbitrary direction, the like this is the fixed point. If you robot one robot can go from 1 to 2, from here any direction, because we are only defining point 1 and point 2. It can go point 2 at with respect to its own axis. So at that time, and this is the motion where robot will move faster. Like we don't require any safety requirement, or safety requirement is not there. The motion will be a fast. If production should be higher, there will be use joint move, because point 1 to point 2, it will take a shortest path, go here to here with respect to its own other axis. If you see the shortest path will be here to here only, straight path, but for its own other axis it will be not the shortest path. For its own other axis it will be another shortest path, and it will take that. Sometimes what happen, you need the straight motion of that particular tool, like a welding. You will do the repair welding in a straight direction. Maybe like if I'm doing welding here, you go here and will do the straight line. At that time, if you use joint move, what happened, welding will do something like this, here to here, here to here. Then welding is not proper, we are getting errors. So at that time, what will you do? Use linear move. You define the robot that you need to go this path to this point in a linear direction with certain speed. You can also define the speed of robot. It will go the linear. That is the third one, other motion which is also inside the linear move, that is called process move. Move P, process move, where if there is a square something like this, the robot, what will the robot do? It will go from here to here, it will pause for some time, it will again go from here to here. So if it is following the welding, what will we do? Welding will happening here in with more, like more welding will happening here. Or if it's painting, more paint will be here. So we don't want that. So at that time, process move, what we are using, what will we do? It will go from here to here directly, but it will not touch here. It will take small radius here, like this, something like this. So from here to here, the motion of speed, if when you're defining 100 mm per second, it will be a constant for the process move. If you are defining linear move from point 1 to 3, what will we do? It takes start here, take 100 mm per second, it will stop for sometimes, and again will start from here to here, again take 100 mm per second, it will stop here. So here we will have the more amount of process. We don't want that. So at that time we use process move. It will take a small circular path here, small. This radius you can define maybe 1 mm, 0.5 mm, depends on the application. And inside the process move, you can also define the circle. If you want to go inside the circle, like you want to do a circular path, what will we do? There are two options. Like if I have a circle here, something like this, let me explain with the marker. like like you have a circle like something like this, and you want to follow the path. So you have two options: linear move, linear join, and linear p. That is a specific move. If you want to use just linear move, what will you do? You will start here, 1 mm here, again give the point. After 1 mm you again give the point. After 1 mm you again give the point. By that means you form a circle which will robot follow. Instead you use linear process move, where you start a point, you give 1 point here, you give intermediate point here, and you get end point here. By that means it will create a arc, depends on this circle radius. You already know the circular path radius, right? So if this is a 25, you directly give point 1 here, give intermediate point here, give last point here, follow the radius is 25. So it, what will we do? It will start here, take center is this, and take 25 radius like this. This also comes into process move only. These two are basic move types. Process move is a special types which comes inside the linear move only. So based on the motion and all, we can specify the robots with work volume, or you can say repeatability and axis. If you are, you can see here all the robot types: ABB robots, Fanuc robots, KUKA, and these are the loads each can carry, and this is the repeatability. The repeatability means if I am giving the robot, like if this is the robot, I give the point, like you need to point here, go to here. So it will go here every time, plus or minus 1 mm in the all the x direction, x, y, z. It depends on the its own characteristic. This is the repeatability means. Load means how much amount of load it can carry at the end here. That is called a load. You can say also a term as a payload. Payload. These are these loads. And what is the work volume? The the 3D space covers by the robot. If it's an articulated arm, 6 axis, it will be mostly a spherical, something like this. If it's a cylindrical robot that I just mentioned before in the before slides, like based on the types of the construction, it will cover a cylindrical. So what will we see here? There will be a cylindrical face. If it's a Cartesian, or you can say a box type, it you will see a box, or you can say cuboid. Depends on the axis and dimensions. And if it's articulated, it will be a mostly spherical. Sometimes few reach points will be not there because of the joints characteristics, because some joints won't be rotated into 360 degree or 270 degree. That's why. So now we already know the all the terminology, motion and all. We will see the robot cell. What is robot cell? Where robot is performing a task, where all the side there will be a fence, there will be a workplace, the operator is also working, and this is called a basic robot cell. So here you can see this is the two robots are working, this is the workspace, he is doing performing a task. Here you can see small green color lights, you can see here green color lights. These are the virtual curtains that you need to give for the industrial robot. So what are the standard work cells? The Ferris wheel that we already see, where the whole workpiece is rotating here in one particular axis. This like this, it is rotating something like this. Then the single station, you know the workpiece is not going to we are not using workpiece in another direction. What will you do? You give fixed fixture, there will be a no rotation, that comes as a single station. If two single station are working behind, like something like this, in front like this, one station here, one another station just behind this, that calls back to back cell. And this one particular robot or two robots or maybe three robots are working together in single cell, something like this. You can see there are two cells here, one curtains here, this is one work cell, this is one work cell, but only one robot is working, maybe two robot is working. that called two station inline cell. Two robots are working together. So if you are working with industrial bot, you need to take safety precautions. You need to give interlocks. The person should not go inside the work cell. You should give emergency stops wherever is possible. You can see here there are many safety like emergency stops here. You can see here is one safety like emergency stop, and there is a light curtain. You can see this way yellow lines. This yellow, it will create a virtual curtain. One if one the person is going inside, it will detect and the robot stops working. Sometimes if it's malfunctioning, robot will continuously give the start working. It will not stop. It will break a workpiece. It will break some surroundings, or it will break itself. There will be a damage inside the robot as well. So if you are working with industrial bot, you need to consider all of this. Safety should be there, because the industrial bot is not meant for collaboration with humans. So if you are selecting a particular robot, you need to take what is the capacity based on application, payload capacity. Yeah, I want to carry a 5 kg weight, 10 kg weight, 20 kg weight. Depends on that. You first, there is like selection criteria, like I want to take 10 kg as a payload. What is the reachability? I want to go far beyond 1000 meter, 1.5 meter, or 2.1 or 2 meters, depends on that. And what is the application of that particular robot? I want to use for the welding, I want to use for the painting, I want to use for the pick and place. These are the selection criteria. Once you have the selection criteria, now you go to the site of that particular, maybe ABB, KUKA, and you can compare that whether these specifications are matching that standard robots or not. If you have, you already select the robot, you can ask for that. Now you purchase the robot, how you justify, like this is the like investment of 30 lakhs 40 lakhs for industrial bot. And if you are doing with the safety, it will maybe sometimes shoot up to 60 lakhs 70 lakhs. So how you justify that particular robot? By high volume demand, like whether my demand is there on mm, like in a factory, how much cost it's involving. If the particular operation is performed by the labor, I can avoid that cost. Of course quality is improved. And if robot is working, productivity is definitely improving because it's a faster. So till the here, anyone have any doubt? This is the basic terminology of all the industrial bot. Anyone have any doubt here till here?
Friends, if you have any doubt, you can raise hand in the Zoom. The raise hand option is available when you click on participants in the participant list on the right hand side bottom corner. Or you can type something in a chat box.
Yeah, you can type in chat box too. Oh,
I think we can go ahead, Jugal.
yeah, I think you can go ahead. So I hope like you all understood all that basic terminology. So after you decide the robot, there are two types of teaching, or you can say programming a robot. That is one called online teaching, offline teaching. Now suppose you are doing for the welding, you are using that particular robot for the weld. So what will you do? You have a CAD model of that particular model, like workpiece. You go to the workspace, work cell that I just mentioned. Physically you will go, you do the setup in the robot, you perform the task that, like, for the this particular building I will set up this is the amount of current, this is amount of voltage that I require, this is the amount of speed I require. You perform this task, you will set up the robot, and you perform the wheel sequence. Like if this is the square type wheel, you will give, I go here, first I go here, then go here, and then you go here. That after that you will measure, or you can say mark welding points, like from here to here, how you will go there, like linear joint, like you are using process move, you are using linear move, you are using joint move, depends on the application. And then manually you teach the robot from starting you will take the robot endpoint here, then go here, you see in between you will save the points, like from here to here you need to save points, like first my robot end will come here, then come here. It will only follow path. But what about the giving the value of like how welding will start? You will give one intermediate input that from here to here welding torch should be start. By that means once robot reach here, welding torch will start and then it will follow the path. This all comes as a manual teaching. Once this done, you will take a test run whether it's following the same path. Do we have any error? Are we having the proper accuracy for the particular process? Whether the robot is following the repeatability or not. If there is something different, or you can say there is a change that you need to require, you will do the final programming for that and you will change all the parameters in final program, and then you will give take all the final program and you will start performing the task. This is the online teaching where you physically go to the work cell. But what if you don't have robot but still the person, or you can say industry, asking for the program? What will you do? You will do offline teaching. You have everything. You have a CAD model of the robot, you have the CAD model of workpiece, you have CAD model of work cell. You also know the weld sequencing, or you can say paint sequencing, all the sequencing. You have everything. But how you perform a task for teaching? On that scenario, what will you do? You do virtual teaching. You will take help of the some simulation software where you will import all these CAD models. You will try to do the virtual teaching, and when then you will try to do the test run whether it is following a path or not. Suppose like I have one more software that is called the Octopus. i, I hope you all see the factory scenario here. So don't know whether the factories like having all this. They give me this, like I these are the tentative layout of the factory, and I want to simulate the particular robot. In this scenario I am simulating the AMRs. The what is the path, what are the points where robots should go, I will simulate here. Whether it is performing the task, whether it is colliding something, are that robot is giving the repeatable outputs. I will perform all the tasks here and then I will transfer the data to actual robot. So here as you can see, I simulate here four different AMRs here. I will play the simulation. So all the AMRs will come in the station. It will take part. You can see here, it will take parts. Whether it is performing a task properly, whether it is colliding or not, we can everything see in this kind of simulation. So it is feeding right now. It is taking part from here and feeding to the station. Similarly, it is for AMR. We can also use this similar thing for the industrial robots, or you can say collaborative robots. Now, what's the comparison between industrial bot and collaborative robot? Basic operations, basic parts, everything is same. You can see here everything is same. Just the thing is here in an industrial robot, you have safety consideration. Human cannot work with a robot, or you can say along with a robot. There should be a fence, like fence for the safety. Inside that only a robot can work. You can see here. But if we are using collaborative robot instead of industrial robot, human can work along with a robot. There is no need of extra safety here, because cobots are meant for collaboration with human. It has its own safety precautions. When like it is touching the human, it will slow down its speed, sometimes stops as well. So this is the basic comparison, basic terminology. All the joints that I mentioned, move, linear move, joint move, process move, or you can say all the coordinates, all the applications based on the end effector, everything is same. Everything is same. Just the basic thing is it can work along with the human. You can see here that the person is touching the robot, still it's working. Here robot is giving the guide to the person that you need to work here. This is the basic comparison. So you already know what are the issues with industrial bot. So that's why we are using collaborative robot. It can work along with the robot, humans. There is no need for extra robot safety. It is meant for the safety, like space safety work. No need of fencing required. There is no power or force limiter required. So by this means, if there is no fancy like fencing safety required, by this means you can avoid costing. So if particular robot comes, industrial bot comes in with a 30 lakh, like an integration cost that is called as safety curtains, and some sensor where a human cannot inside, that comes as a integration cost. It will added up maybe 20 to 30 more. By that means you have 50, just a basic robot. You don't have any other end factor, nothing. But when you take for the same application, you buying collaborative robot, it will directly is maybe 20 25. That's over, because we don't require any safety precautions. Improve a productivity by HRC, that is human cobot collaboration, because here robot can guide people or people can guide robot as well. There will be a two options, vice versa. We have two both the options. And we can also improve a safety by using cobots. Sometimes what's happened, because of the fast productivity, a person directly go inside the robot, like work cell, and it will create like damage for the human, maybe injuries and accidents. But here it will work along with the robot and will not create anything. That's why we are using the cobots. So I just mentioned about the all the terminology for the industrial bot. Same here for the collaborative robot. Here I am taking example of your universal robot, collaborative robot as an example. You have base, you have shoulder, you have elbow, wrist 1, wrist 2, wrist 3. Same as an industrial bot. Same, we have a control operator panel where we have IO modules, digital input outputs, analog input outputs, USB, Ethernet, everything. You are teach pendant here, power button, emergency stop, the programmable cord, and if for the collaborative robot only, we have one extra function. You can see here 2 3, that is called free drive button. We don't have this in the industrial bot. We only have free drive button in collaborative robot only. What it will do, you will press that robot, you take your hand and take the robot joints whenever wherever you want to go. We don't require any axis or something, just press, nothing. You take that particular button with right hand, take robot hand, or you can say articulated arm with the left hand. You need to continuously press that particular button for a free drive button, and you can take that particular robot in any access. If you want to program in such a way, that what will you do, you will press this button. Suppose for this robot you are programming, this is a point 1, this is point 2, this is point 3. So there is a two option. This, if you see here, there are the axis. You can take this axis and robot will perform the like linear motion from here to here. This is one option. Second option, press this button, take that particular robot with your hand and directly drag it to particular point and stop that particular point. Like uh, right now you are pressing that button and go to the particular point. Now just like stop that particular button by pressing, don't stop push. And what will it do, it will directly come here, give all the safety measure, and it will directly take that point data inside the robot. And you can, by that means you can program the robot. Same thing happen here, you can do here or here. Now how you can program the particular collaborative robot. So this is the simulation model, simulation program. This is the actual program. So here you can see in the simulation, you can see you are giving the points 1 2 3 4. Home position means like now this is the point. Now if suppose I'm using the camera, this is the camera, and these points, like you can see here, this axis here, you can see here, this axis, these are all the points that I am giving this. These are the points that I need to follow the particular path. So I will give that particular path, and this is the main program where I'm calling the function, just like C++, you are calling a function, right? Similarly, I am calling the function call approach. Approach is one function. Scan on is a one function. Scan off is the function. Retract is a one function. You can see approach function is here. You can see here. These are the sub function. Whenever you call that particular function, it will go there. This is the main program is only following, and we are calling that function by its name. Now in the simulation, there are some other terminology. In actual, there will be another terminology. So if I want to program in a main program, a main robot, main workspace, you can see this is the main program. This is my main program. Only this. You can see robot program. This is the only thing. You can see here. This is the same thing. This is the same thing. These are the thing. Now for going to particular point, you first need to give the TCP, that is tool center point. TCP tool center point. Tool center point means the end effector's center point. If you are attaching something with end effector, then tool center point will be at the end. If it's a 2 degree of freedom, like 2-finger gripper, it will be a center. 3 finger freedom, it will be on center. If it's a suction cup, take the CG of that particular suction cup plane, and it will be a tool center point. You need to give that robot's tool center point will be this. You are giving as this is the point minus 0, 1.00 something. Now what will you can do? You can directly give with help of base coordinate system that I just mentioned before, like move j joint move to this coordinate minus 2.57 minus 1 point. This is the x coordinates of xy direction. You can directly give that coordinate here. These are two coordinates. This is the one way to uh, uh, teach the robot that you need to follow this path. This is the one way. Another way is with defining a waypoints. Here you can see we are using move because we want to move the from here to here. There is no restriction for the linear path, so that's why I am using move j. So it will go from here to here automatically with respect to move j. But if I want to follow the straight path, I will use move here. You can see here. Now suppose you are using a camera. How will you define that I need to take picture of that particular thing at this point? By that means you are giving this command set DO, digital output on, just like if and else condition. Once you reach this position on this is the simple syntax.
Jugal,
Hello. Uh, Jugal
Jugal,
is unmuted. Please unmute him.
yeah, yeah,
Can you hear me now?
yeah, we can hear you now.
Yeah, sorry, there is a power cut in my side.
No issue.
Yeah, let me share screen again. Do we have any question till here?
No, Jugal, till now I didn't receive any questions in the chat box. All participants, if you have any questions, you can type in a chat box. At some interval, we'll take up those questions.
So this is the basic programming of a collaborative robot. Similarly, if you are taking another collaborative robot, the same thing you can follow. Same thing. Just the terminology will be different. If instead of waypoint, there will be another name. If you are talking about the other robot like Kuka, the instead of waypoint, it's giving the point, only a point one, point two, like that. Terminology is different. Basic thing is the same, like that. So let's take some applications here for the collaborative robot. You can do the screw driving, of course. It's for the sub assembly or assembling thing. Pick and place for the particular operations. You can do welding as well. You can do use for the injection molding for with the suction cups. You can do assembly. You can do the painting. You can do the deburring or sanding or polishing for with the help of robot. You can perform the tasks like drilling, dispensing this like cylinder guns are also, or you can also guide the operator with help of UR, and packaging and palletizing. Let's take see the one video here for the application of COBOT. Here you are seeing a different applications, palletizing, machine tending. Yeah, now it's a pick and place with the suction cup. This is the AMR collaborative robot. Here we have a two grippers alongside. Right now it's palletizing. Right now it's scanning the parts with the help of camera, and alongside the AMR is also there. Collaborative arm is basically a normal human arm. You can see here right now, like, let's see. If the object is not in proper direction, it will push the object automatically, like this. And this is the advancement that only comes inside the collaborative robot. Now this is the dispensing, cylinder dispensing for the windshield. Here they are using a FANUC collaborative robot. Now this is the traditional. If you are using collaborative robot, it's the smaller in size. So here you can see that human and robot are working together, where human is putting the windshields and COBOT is performing the task. You can see here. Now sometimes the application needs two grippers with the vision camera. So we have also option of the camera that will put it inside on the end effector. It will take the pictures of the parts, detect the parts, and two grippers. You can see here two grippers are picking a part at the same time. To accommodate the time. You can teach
robot that you need to pick that particular object in such a fashion. It is also possible. Vision guided picking, like it will take a picture and then pick. Like this is the external access that I was just mentioned. It will we are giving external access. Two or three robots can work at the same position without colliding with each other. That is the best thing for the particular workshell. See, we have two different robots here, UR and Cartesian. We are using it for the machine tending, for the injection molding. Now you will see here, operator is working along with the COBOT. COBOT is giving the parts to the operator for assembly. It will also guide where to put the part. It is guiding right now. I hope these applications are clear with you. Like collaborative robot will work along with a human without any safety issues. When the human is working with a robot, there should be some issue, like safety should be for the consideration. But cobot are meant for the safety. When it is detecting some kind of force, it will slow down, it will stop, or it will change its own path. So we in the video we cover almost all the applications for the inside the like for the industry, if you clearly see that. Now let's jump to the AMR now. The AMR I just mentioned, that is autonomous mobile robot. You can see different makes here. That is Mir, Bastion, then the Omron. So this is the first patent Shanky that just patented in 1972 with help of Lisp programming. That is the full form Lisp. And this is the basic AMR where we have a camera, the motor drives, and some applications. This is the basic AMR. So I just mentioned for the industrial arms, that should be a caging thing that should be required, or safety precautions should be there. Now if industry is using AGV, autonomous guided vehicle, there need a fixed path. You can see here, this is the AGV, there should be a fixed path. You can see here, there is a white color line. It will only work on that, it will follow that particular path. It is kind of path following robot. And if some obstacle comes in between, it will stop working, it will not go beyond that particular thing, unless the one operator go there and remove that obstacle. After that only the AMR will start working. So by that means, we don't have flexibility that robot will reach to the end position. So for that, so what happened, we don't have the availability of material on time. Line stoppage will be there because the material is not going. And if I'm talking about this industrial bot and this magnetic path thing, we need extra space for the installation. And if the operator is using a forklift or something, if it comes in between, the operator will not know that AGV is coming, by that means we have the kind of accident thing. So material will not go because operator is not performing a task or sometimes causing the accidents. These are the issues. Because of that, we are using AMR and COBOT technology. So by using AMR technology, we are flexible to give the material replenishment, because the AMR is avoiding the obstacles and it will reach to the end at any like without any changing the path. It will reduce the wait time, because the AGV will stop but AMR will not stop when obstacle will come. The labor cost reduction, because right now AMR is performing the task of particular labor, and we can avoid that. And it can also work collaborative with people. So what is the AMR? Basic information. It is like it has the artificial intelligence machine learning ability, which will detect the obstacles. Now you can see here there is basic components here. Like if I'm taking example of MIR, mobile industrial robot AMR, we have ultrasonic sensor, 3D vision camera, 270 degrees seek lidar, servo motors, and on top of we are programming into ROS. ROS means roboting operating system. So lidar is kind of navigation thing which will detect obstacle in point clouds. If I'm in front of this lidar, it will give that the some kind of obstacle is here with respect to this. Like if I'm putting in such a way, like these are the small red you can see here. By this means it will give that here. Ultrasonic will detect, like what if the obstacle is transparent, because it's a laser, it will pass from the transparent. At that time we are using ultrasonic sensor. And 3D vision sensor for detecting the obstacle in front of that with depth and height. So for doing that, after all this, we are programming in ROS. ROS is basically robotic operating system, where you are using C++ kernel level programming and Python as a basic programming, where you are defining all this to perform a task. And for the slam technique that you are giving, that you need to perform all the tasks inside this particular map. That mapping, creating a mapping, is called a slam. And when then lidar sensor and vision camera helps AMR to for the object detection. There are some also features coming along with the like AMR, that is auto charging. It will charge automatically. We can set that if the battery of particular AMR is below 20%, it will directly go to the charging station and it will start charging. It will auto collision avoidance. It will avoid obstacles. It will not stop. We have Wi-Fi connectivity. We have the LED lights, like you can see right now blue, depends on the application, performing a task it will change its lights. We can do the different application on top of the AMR. And you can also give the voice inside the AMR, or you can also like give the signals. You can maybe a voice kind of thing, like go away, I am coming on the way, something like this, and it will have inbuilt speaker. It will give the volume voiceovers. So if we go inside the AMR, we have a different sensors. Like I already mentioned seek lidar here. We have ultrasonic, the motor controllers, then there is a battery, there are safety PLCs, IO modules, cameras, and this is the speaker. These are the basic, like these are the actual basic components for the AMRs. If you take any of the AMR, not only a MIR, if you take a Omron, you can take Fetch. These are the basic components. There will be a lidar, there will be ultrasonic, there will be a camera, there will be a motor drivers, basic batteries and all. These are the basic components. So how now you know you already have the AMR, how you are programming it. So you have a web based application. You can operate through the mobile, through the laptop, or you have also a remote control joystick kind of thing. You can also do the navigation mapping with help of that. Right now if I am mapping particular area, you can see here in mobile I am seeing that particular map. This is the map. Once the map is created, this is the map with help of lidar and ultrasonic. Now you are defining the points where AMR should go, how AMR should go, and what are the properties of that. So here you can see staging area. That means that are charging stations for the AMRs. This robot blue color is points where AMR should go. Red lines is forbidden zone. AMR should not go inside that area. This is the yellow zone where AMR will give the like voice or lighting things, and these are the docking station that AMR should go inside that for the particular application. Now if you created this map, you can save it in map format and PGM format, YML format, or PNG format. If you already have the map inside of AutoCAD, you can directly use that. You can change that AutoCAD file DWG into PNG and directly upload that shop floor map inside the AMR. It will directly starts working. That is also possible. So these are the suppliers, or you can say competitors for the AMRs based on the application Fetch, Omron, Mir, and they provide the different applications: pallet, conveyor, hooking solution, or COBOT on top of AMR. You can see all the applications here. So these are the applications. Maybe we will see a video in soon, like AMR hook solution, where there will be a hook. It will uh, take the go the particular station, put like grab that particular cart and take it with it. There will be an on top solution. On top means there will be some kind of pallet we are putting on top, and it will AMR will go to and forward at some position. If we have a conveyor system in the factory, and if we want conveyor only on top of AMR, that is also possible. Sometimes what's happened, if we are using as a conveyor and in top of solution, we need one operator to put the thing from AMR to the actual conveyor system. Instead we are using a conveyor system where AMR go as close as possible to conveyor, and will start conveyor thing. It will shift that particular load onto the main conveyor. That is also possible. And COBOT on top of AMR. AMRs will be there, and one end or one point, a COBOT will be there. And what will we do? It will go to the station, do the pick in place, putting the things, putting the beans, and it will take on to the AMR, and it will start working like this. Let's see the video of the AMR now. So right now it's creating a map. You can see here with the help of joystick. It have like the person having the tab in its hand. It is creating a map. You can see here. For creating a map, you just need to play with the joystick on the floor. It will start creating the map with obstacles. These black solid lines means that these are fixed obstacles which will not change, like walls maybe, or gates maybe. Right now it is creating a map. So once a map is created, and if you find something is not needed, like maybe a dynamic obstacles, maybe a cart, something like this cart, what will you can do? You can erase that particular cart. This is the cart. This is a like thing, like it will be not fixed, depends on the application, it will move. So what will you can do? You can remove that. Now for the walls, you can also apply it. Sometimes what happens, you are creating extra walls for the better resolution for the AMR. You are creating a map. So right now it's creating extra walls here, so it can detect that walls. Now you are defining the path that you AMR starts from this point, follow this green lines, and this is the second point. And this red line means you cannot, AMR should not go beyond this line. This is called a forbidden zone. Now you will see the application. This is the on top application where AMR is waiting for the lift to open. It will also communicate with the lift that I am here, please open. Once the lift is open, AMR will go inside, and it will change the map accordingly to the floor. Right now, which is in the first floor, and AMR is going to the second floor. We can also set as like your AMR is changing the map like from first floor to second floor. This is the hook solution when the cart is pulling by the AMR just like a tow truck. So you can see there are the obstacles, but it will not stop. It will detect the obstacle and it will avoid that path particular. Right now you can see this is the straight path that it should follow, but it's not going a straight path because that's the obstacle. It will detect that this is the obstacle. I will avoid a path and I will take another path. So we'll see like in the soft floor if the operator comes in between. So AMR will detect that a person is here. This is the straight path I should follow, but this is the obstacle. I will deviate from my main path. I will just turn around and will go. For the AMR, we have also option of self-docking. It will go inside the trolley, lift the trolley, and it will take along with it. Here there is also option if the factory layout having the Wi-Fi switches, you can take that like operator will press the button, I need AMR at this point, AMR will directly go there. It is also possible with the AMR. So here you can see there is the obstacle, it detect obstacle 1, it detect obstacle 2 and avoid the path. So this is the conveyor solution. We are having a main conveyor here. It will, once the AMR reaches the point, it will start its own conveyor and it will transfer the load on top from the main conveyor. If it's in a different direction, like conveyor is like there is a conveyor which is coming out from the layout, and we want to transfer that load to main warehouse. That is also option. Conveyor will give the load to the AMR. And now AMR will start to conveyor and take the load and it will go to the warehouse. So here you see operator switches are there. So it will click the button, it will start running. This is the operator switch that I was talking about. So once the AMR will reach that particular point, what will operator do? The AMR is reached the particular destination. I perform the task. I take all the data like things that I need to require, and it will give the feedback. This is the on-hook solution where we have a 3D camera. You can see there is a QR code here. It will the AMR will know that I need to pick that particular bin with help of that QR code. It will automatically go there, attach it, and it take it with it. We don't need require any extra programming for here. So these are the basic applications for the AMR. Now AMR is having a capability to detect obstacles depends on its like make. If I'm talking about the Omron AMR, it can detect up to 1.5 meter height. If I'm talking about MIR, it can detect 1.6 meter height. And if the hook solution is there, you can also increase the length for the better the turning radius. If it's a COBOT on top of AMR, we can also select the speed of the AMR for the better motion, because we already know that we have the more weight in particular site. For the conveyor, we can set the speed as well. So there are other applications for the AMRs for the like you can say for the defense as well. There is a Boston Dynamics company who is making AMR for defense and also for the factory environment. You can see here there is a 2-wheel AMR and there is a one small COBOT. and AMR having its own like kind of segue thing for better balance. And it will perform a pick and place task, put the box on it, and AMR will take. This is a dog style, or you can say leopard style AMR. We have four legs. The camera things, this is the lidar. The camera thing for detecting the obstacles, and this is a humanoid kind of AMR. To this is all kind of humanoid, but it counts as a AMR because it is not performing the other task. It will just do the pick and place because of its hands and effectors. So we have the lidar here, camera here, and for the motion we have two legs. So if I'm talking about the conclusion for all the AGVs and collaborative robots, so AGV may perform the task, but if comes as an obstacle, it will not perform particular task for the handling, like material handling equipment. When I'm comparing with AMRs, it will be a more smarter, and there will be a flexibility, and there is a AI also available for that. So we don't require intense programming for the EMR, and it can also for use for the labor cost saving, material replenishment, and you can also use multiple AMRs on a single map same time. It's kind of fleet management. And the quality, obviously if operator is performing the task, material handling task, and AMR performing the task, better quality, or you can say faster replenishment will be there. And if I'm using collaborative robots, it will be advanced and smarter, and we don't require the safety peripherals. So in this means we don't need any safety curtains or something, anything. It will starts working as it is. We can take particular cobot in any layout. You don't need to design the factory layout for that particular station. You don't require design that particular work cell. You can take it, this particular collaborative robot, put it in any of the axis, vertical, horizontal, upward direction, at any angle. You can put it as in many equation axis. There is no like like what will I say, there will be a no restriction for that particular axis. It will be it will work. And best thing is it will work collaboratively with the humans. You can guide, the robot will guide the robot, or human will guide the robot to perform the task. So that will be from my side from AGV and MRM. I'm open to question and answer if there will be any.
Yeah. Thank you very much, Jugal. And friends, if you have any questions, you can either raise your hand in the Zoom so that I'll unmute your microphone, or you can type. Jugal, I have started receiving questions. Ravi sir and Amrish sir, if you allow, shall I start uh, sharing those questions?
Yes, yes, please, sir.
Yeah.
Yes, yes, sir.
So, Mr. Viren has asked a question. So how do we teach the robot to detect in real time?
Robot in terms, if I'm talking about the AMR, then it has its own capability with help of ultrasonic sensor and lidar. So what will do, it will generate a point cloud, and it will give the feedback that the some kind of obstacle is there. If I'm talking about the collaborative robot, we have 3D sensors, vision sensors, where you will give the particular model, CAD model, or you are directly taking the photo of that particular object and take that features, lines, edges, to teach the robot, collaborative robot, that you need to perform a task on that particular object. It is possible with vision sensors.
Thank you. Mr. Anand has asked a question. Can robot be used for diffusing bombs and IEDs, just like a bomb squad? Can AI and ML applied for the same application of the robots? Can it be used for surveillance of the international borders?
So right now, if you see, like I just mentioned about the Boston Dynamics, it is already in place for the defense. They are using it for the surveillance. I just show the picture of the leopard kind of thing. It is already in place, but right now the all the countries are not using it for the purpose, because it is a high cost. But that are already in place. We can also use for the bomb squad as a bomb squad. You can train with the help of AI that if this kind of bomb is there, how you can perform diffusing it. That is also possible with AI. But for that you need a combination of AMR or humanoid robot kind of thing. So the robot will go that particular place, should be a gripper for performing a task, or maybe a different tools for cutting wires or scanning the data, for maybe you need vision sensors and all. That is also possible, we can use that.
The next question is how it will be cost effective in India compared to manpower available with us.
So for that you need to like calculate the ROI, return on investment. Like if there is a like industry is multinational industry, if I'm talking about, you can take example of Ashok Leyland, General Motors, BMW. So for that manpower cost will be around $20 to $50. It depends where it varies per hour. So by that means you can calculate that, okay, this is if the particular operator is working 365 days, then how much it is costing me with the errors it will done by the operator, like performing the task. If I'm using COBOT and AMR for the same application for particular time duration, how it I am increasing the quality, productivity, then whether I'm able to achieve ROI, return on investment. Maybe if I'm talking about the general AMR, if it costing me 20 lakhs, and if I'm converting that into dollars, it will be around 10 to $15,000, and labor cost is for a particular year is costing me around $20,000. Then within a 1 year, I have the profit for particular labor, for particular operation, and I'm also getting the quality, accuracy and repeatability at the same time. So by this means we can compare the things.
Jugal, one question from my side.
Yeah.
See, in case of mobile calls, some year back it was around 35 rupees per minute.
Yeah.
Then it came down, then became a 1 rupees per minute. Now it's almost virtually free.
Yeah.
Similarly, for solar power, it was around 16 rupees per unit. Now it's almost less than the normal, like 3.2 or 2.8 rupees per unit.
Yeah.
Is similar thing happening in robotics, where the cost of robotics is, it's because of the upgradation progress, the cost is coming down.
Yeah, it is happening because like AMR and cobots are in just in, like you can say, in advancement phase. It's not like people, like industries are slowly adapting all this technology, because it's in still R&D phase. It's not that like fully developed thing just like our industrial robot. This is the still in an advancement phase. Once it like reaches to full advanced phase, it cost will drastically change. And we can see like I'm talking about the only AMR, the seek leader cost us around 5 lakh rupees, only one seek leader. But still there are right now what happening is advancement inside the algorithm, for the algorithm, for the lidar thing, the basic things, it is still going on. Once it is fully advanced, that 5 lakh rupees cost will drastically changes to 1 lakh or 50,000. There are few leaders also available for a lower price, but it is not giving that proper accuracy. These are also available, but if you want proper accuracy in all this, advancement is going on, and maybe next 2 3 years the cost will be coming down.
Okay. Suppose somebody wants to specialize some of the technologies in robotics
Okay.
as a researcher. Which is that area?
uh, that is very actually a very broad question. It depends on the like how you want to use. Like if I'm talking about myself, I'm actually working with like all the peripheral devices, machine vision with robot, lidar with a robot, programming with a robot. It depends because like robotics is still in advancement phase. Nothing is like uh, nothing is perfect right now. You can do anything with robots. If I'm taking the example, just a few days back we have the webinar, like international conference with RIA. and it there mentions CEO of General Motors mentioned that robotics is still in a developing phase, not is a develop, where you can use other peripheral technology, machine vision, like IoT, AI, ML, machine learning, artificial intelligence, or you can say direct mechanical kind of linkages. Everything you can use with robots, and and you can create your own applications. That these are the kind of things is happening right now. So I cannot directly say that this is the application which should directly pursue that. You can pursue as many application as you can. So there are the combination of the different applications, or you can say streams.
Thank you. With that, all the question on the chat box is over. Participants, if you have any questions, you can raise your hand so that I can unmute your microphone and you can speak to Jugal. Yeah, Ravi sir, Amish sir, I think there's no more questions.
I think I would like to ask something to Jugal. Hello.
Go ahead, go ahead sir.
Okay. Actually, there are many students probably who have joined us right now, and want to make a career in a robotics. So,
Okay.
Jugal, what would you like to tell them that what they should be doing?
Okay, by that means like uh, if I will start with the basic stream. If I'm talking about myself, if you are right now pursuing a mechanical stream and you want to make a career in robotics, just start with the basic mechanical concept, like how the degree of freedom works, how you can change that, basic mathematics and concept, and this will help in learning a basic robotics, how the robot is performing the task, how you can do path planning. That all comes as a basic mathematical things. If this is the if the student is from the electrical side, electrical electronic side, then you need should know that if the robot should move in this speed or this thing, this kind of sensor should give the feedback in this scenario, and my data of that particular sensor should go in particular motor of the robot in a such a way that it will perform a task. If I'm talking about in general basic stream, the robotics having the capability of all the basic things like electrical, electronics, mechanical, computer science, everything. So there is no like specific thing where you can not learn the robotics, though there are the possibilities that you can do advancement by joining the other streams with a robotics. So if I'm talking about the AI and ML, that is actually comes under the computer science. So how the algorithms works for the robotics. So if we are talking about the normal algorithms, it will not work for directly the robots. You need to change a few parameters for the robots. If you're talking about the mechanical streams, how the robots are performing a task with respect to its mechanical linkages, or how that torque requirement is power giving the like fulfilling the task. So if you want to pursue robotics, there is no barrier for any of the particular stream. You can take the robotics, build a robotics career. And if you want to do the researching, like specific to research in the robotics, for right now, if I'm talking about the general scenario, actual scenario, robotics alone, it's like kind of developed thing. If you combining few other streams with robots, then there will be a more kind of research. The like how will you research something that is already developed? It is already developing. The basic robots is already available from since 50 60 years. How you are using robots is already there. How you are performing a task, how you are using other streams for the betterment of the robots application, you can do research in that. That is all available right now. There is plenty of research available right now.
Okay. Okay.
Basar
Thank you
sir,
very much.
Basar sir,
Yeah.
please.
Uh, Jugal, thank you so much for such a nice webinar. My question is that which kind of algorithms are used for the vision programming of the robots? You mentioned that many computer visions applications are there for the automation and detection purpose. So which kind of algorithms and which kind of programming is currently used?
So, like, if I just want to do the pick and place thing with help of a vision camera, what will I do? I will take a picture and I will start taking out the features of that particular object. For that, what we are using is feature detection algorithm. It will depends on object, what kind of features we are extracting that, and we are giving that feature to the robot. If I just want to pick in place, so what will I do based on the application? I will just give the width as a feature. I will give the command the robot take the picture, take out that particular feature from that object, and that length position of that particular viewpoint, it will feed as a feedback to the robot as a coordinates xyz, and end effector will go to directly that point. It's kind of feature detection. In the there are some application where just you need a camera to for the presence or not. At that time, what will you do? You can use x-ray, low level x-rays. You can use lasers feedback, 2D lasers like laser, where you will have the profile. And you what will you do based on the like datum line? You will give that this is the my profile with respect to this datum with in x direction or y direction, and now you need to perform the task. That is also possible. So that algorithm will actually depends on the application.
Okay, and these algorithms are implemented using OpenCV, MATLAB, or something else?
You can do that, and also it is directly available with the camera. If right now the smart camera is available with the industry, and based on the application you can directly select that I want this feature, and in the background it will directly select that particular algorithm. That is also possible. And I just mentioned for the AMR that you can use a ROS, robotic operating system, where Python and C++ as a kernel level programming is there. So there you can dedicatedly use that particular algorithm to fetch out the data, or you can give out the data. That is also possible. Then you need to create a particular algorithm programming in the Python, or maybe MATLAB will not work directly here because it's a standalone application. You can integrate like the standalone robot with MATLAB system and some controller, but that will not directly work with a robot. So for directly on robotic side, you need to make the in Python, Java maybe, like Java is also working, C++ is there. You need to create a algorithm in that.
Thank you so much, Jugal, for
Yeah.
valuable inputs.
Anyone has any other question?
Like, Adil sir has a question. Let me bring him. Adil sir, please go ahead.
Hi, Jugal. How are you?
I'm fine, sir.
Yeah. Jugal, just to help all the students over here, can you just help them understand how you got interested into robotics? From where did you start actually into the field of robotics?
Oh, okay,
That
okay.
would actually help them in understanding. And of course, you had already briefed you about your journey in robotics, but where you start is a very important part,
Yeah, correct, correct.
particularly for students at this age.
So like
Thank you.
when I finished my 12th, like I go to the like you can say market study, like them specifically mentioning that term, like what is that particular technology will come, maybe future, as a future. So right now you will see everything comes as automation. All the industries are asking for the automation, and from that I take just one idea, let me just do something that will help me to grow the career. I'm not specifically talking about the robotics at that time or maybe automation. Just have a thought. I may not create career in that, and then I take admission in Navrachana, and we have few curriculum that will give the information, basic information in automation or robotics, how you can perform the task with sensors. And during that time period, I come to know that these are the things which will help me to gain the knowledge of for creating like projects in automation area. And by this means I gain like, I what will I say, I got excited that I come to know, like basically I come to know that these are the basic things that I that will help me to create something. And later once I finish that as a masters in mechanical, sorry, btech in mechanical, I have full basic knowledge of that, how you can perform a, like how you can actually design robot, how you can integrate sensor with robot, how you can perform a task with robot. And all this will help me in my masters that I did in mechatronics, where in mechatronics all the basic things, sensor, how it works, how machine vision will works, how robotics is designed, how path planning is there, how you can integrate other sensors with robots, how you can integrate other sensors with industries like normal automations. All this knowledge will help you to make something, or you can say you will that will guide you to make career in the automation area. Now I'm not specifically talking about the robotics, because robotics is a subset of automation.
Okay.
Thank you, Jugal, for that. Actually, it will help our students to understand the whole scenario about being. It is just not about the robotics; it is about the automation that
Yes,
they need
yes.
to. Thank you. Yeah, please, sir.
So anyone else has any other question?
No, sir. Right now, the chat box, there's no questions and nobody
Okay.
has raised a hand.
Okay. Then I think Jugal, share your share your email ID with me. I'll share it with the students,
Sure, sure,
and if they will have any question in the future, I think they may contact you. Right?
sure, sir.
Okay. So thank you very much, all of you, for joining here, and thanks a lot, Jugal, for taking out the time from your busy schedule. And I think the way you explained. I think I'm not the person who has worked in a robotics, but I could also learn many things from your session. So thanks a lot for that. We all are very proud of you, of what you are doing, and we wish you all the success and all the best. Thank you very much for taking out the time. And whenever you come to Baroda, you kindly come to meet all of us. We'll be very glad to have you at university.
Sure, and thank you so much for giving the opportunity for this, sir. Thank you so
Yeah.
much.
Okay. Thank you very much,